Hey, physics class. So this is what our notes ended up looking like at the end. It's a bit hectic, so let me lay this out for you nice and neat and orderly. So the first thing that you need to be able to do is to estimate the angle and length of your roof. Estimate the length and angle of your roof. You can do that with a photograph. You can do that with a good estimate, but it should be actually based on your roof. So once you've got a length and an angle of a roof, it means that you could make a diagram looking something like this. You've got some angle and some length, R. I called it R before, so I'll just call it R again. R is the length that you have to slide down. Now, the question is to describe the motion of someone sliding down your roof. And that means that you're going to need the following information. Use it like this. First of all, let's just make sure that we've got the person or object or whatever it is on the roof. And remember that there are forces pulling it down. That would be mg sine theta. And that there are forces keeping it up. That would be coefficient of friction, mg cosine theta. Okay? And in order to find that motion, you're going to need to find an acceleration. Okay? Now, the acceleration is going to be the force divided by m. So if you work the math out, you end up with this. I'll write it in a nice color so it looks pretty. The acceleration is going to be equal to that without m minus that without m. G sine theta minus coefficient g cosine theta. I guess I could also factor out a g, but I didn't. So once you find that acceleration, and that's your distance, then you can use this equation. But solved for V2. Just remember that this delta x is r. That a is whatever you find from here. So once you find the angle of your roof and you find the length of your roof, you should be able to do this. Last point, we were using a coefficient of friction equal to 0.3. So give it a shot, and let's see how Santa will do. By the way, Santa also fell off the roof, so let me just throw this in here. Also, how fast would you hit the ground if you fell from your roof? If you fell from your roof. Similar equation, 2ax delta v. It's just that a would now be gravity, and delta x would be the height. So if you can estimate the length of the roof and the angle, you can find out how fast you'd be going at the end. And if you can estimate the height of your roof, then you can figure out how fast you'd hit the ground after you fell. Anyway, hopefully I didn't miss anything here, so good luck.